Hey, Walter Sorrells back with more tips for the knife maker. Today, making screwdrivers from scratch. So today, making screwdrivers. Specifically in today's project, we're going to make parallel face or parallel tip type screwdrivers. These are sometimes known as gunsmithing screwdrivers, though there's really nothing specific to gunsmithing about them. The basic theory is that unlike the forged type screwdrivers that we made in an earlier video, these are actually going to be milled. These are going to have a parallel face so that it fits right dead into the slot and has less likelihood of popping out under load. I'll be making all of these from 01 steel drill rod that you can buy from Grainger, MSC, or tons of other places. We'll use two sizes, 1/4 inch and 3/16 inch, but depending on what sizes you want to make, you can use any appropriate size of stock. If you watched the last video, for that one I used very simple tools. If you're looking to make screwdrivers and don't have a shop full of fancy tools, you might want to take a look at that video first. So recap here, this is part of a set of tools that I'm making for my son Jake for his 21st birthday. For more on that project as a whole and to see how this whole thing came together, click the link in the cards in the description. Anyway, for these screwdrivers, I'll be using a mill and a 5C collet block. If you have a mill, you're probably familiar with 5C collets, but if not, they're little sleeves that are used to hold tools and material. In this case, I'll be basically clamping a piece of 01 in this precision squared block using the collet. Then I'll tighten down the stop on my vice jaws like so, using it to index the location of the block, so that I can flip the block over and repeat the operation on both sides of the screwdriver, and they'll come out dead even and perfectly symmetrical. Next, I'll use a little edge finder to locate the center of the rod. The way they work is that they spin around, and when the little feeler at the bottom breaks free, you've located your edge. So I'll zero the digital readout on my mill, then go to the other side and repeat the process. Now when I divide that number in half, we've got the 0 at the center line of my little future screwdriver. I'm aiming for a 30,000th inch thick blade, so I won't bore you with a bunch of 6th grade math, but now we've got our 3/8 inch end mill set to mill off 15 thou on this side of the center line. I'll just mill forward so that I get about 20 thou past the center line of the end mill. Not the screwdriver center line, but the end mill center line. That will result in the final part of the blade, the very tip of the screwdriver in other words, being completely parallel. Now we'll pop the vise open, flip the block over, snugging it up against the index block, and we can repeat the last operation exactly. And we'll have a perfectly symmetrical blade on our screwdriver, 30,000th inch thick. Now this begs the question of what the theory of this type of screwdriver design is. The idea is that by having a very precise, straight-walled face on the business end of the screwdriver is less likely to skip out of the slot. Gunsmiths like this because it decreases the likelihood of marring a nice finish on an antique gun. The nice thing about this is that if you want to make a whole set of screwdrivers this way, once you set your center line, it's just a matter of popping in one shank or collet after another and more or less repeating the same thing over and over until you have a big pile of screwdrivers in all kinds of different sizes. Instead of doing that, however, we'll complicate things just for the fun of it and show another way of accomplishing exactly the same thing. In this case, we're using a tool called a spin indexer. We're doing more or less the same thing as we did with the blocks, but in a fancier way. A spin indexer uses 5C collets too, but has the ability to make extremely fine angular adjustments. In this case, we're just cutting at 0 and 180, so the tool's complete overkill. But who cares? This whole project's an exercise in overkill anyway, right? But as you can see, if you wanted to make a hex driver, a Robertson drive, anything like that, you could use this tool to mill a square, a hex, whatever it might be. But in this case, we just mill one side, pull the pin in the index plate, spin it 180 degrees, rinse and repeat. 2 drivers, 2 different approaches, exact same result. Now we'll heat treat them exactly the same way as we did the tapered blades in the previous video. Check there for details, but here's what we do. Heating to 1500. Quenching in oil. Then tempering in the heat treating oven. Again, you can use Mom's oven in the kitchen at 475 and you'll be fine, but we're going at 600 Fahrenheit for a spring temper. After they're tempered, I'll clean up the shanks by chucking them up and sanding them as they spin. Notice I've put some masking tape over the tips in order to leave them dark. This is totally an aesthetic detail and has nothing to do with the performance of the screwdrivers. Next, it's on to making the handles. I'm going to turn them on a lathe. Now, if you don't have a lathe, check the previous video for a low-tech approach that will still produce a perfectly serviceable handle. I've got a gob of different types of wood, so in this case, I chose zebra wood. By the way, something I strongly recommend to any knife makers. You can buy really small pieces of wood that are chopped up already for making knife handles or pen turning or whatever. But if you look at the price per board foot, you're paying a ton for them. If instead you buy lumber by the board foot or in the form of large turning blanks, you'll pay way less money for it than if you buy it piecemeal in these little bitty shapes. And you'll have the right size for any project, large or small, because you can take a big piece of wood and chop it down. Anyway, I'll begin by chucking up the spindle blank. Then I'll lathe them. Yeah, that's me, boss woodworker, showing off all the technical words. If you own a lathe, you probably know how to do this better than I do, but here's the procedure I used. The key point is that we're going to use a 5/8 inch ID brass tube as a ferrule. That part of the handle, right down near the shank of the screwdriver, has to be turned flat and to fairly precise dimensions. The rest of it you can do however you want. Cylindrical, tapered, keep it kind of square, whatever, doesn't matter. By the way, I didn't necessarily film every single operation that I did these 2 screwdrivers from, so you may see me showing a couple of things with other pieces of wood. Same operations, just different screwdrivers. I'll cut down to the correct dimension for that little ferrule portion using a parting tool. You could use a pair of calipers, but in the spirit of total overkill, I fabricated this little gauge to measure this diameter. If you use a gauge like this, by the way, you want to hold it very carefully. The idea is to just barely kiss the wood. If you do that, you're fine, but it can snatch this thing out of your fingers if you bear down on it too hard. There's no shame in turning the machine off to gauge it each time. In fact, that's by far the safest way to do this. Now that we've got that measured, I'll go ahead and turn the rest of the handle. You can do this with a gouge or a round nose tool. After I'd done a couple, I was able to crank out each one of these in about 5 minutes. Once the turning is complete, I'll use sandpaper to smooth things out. Notice that I don't mess with the portion of the handle that will be hidden by the ferrule. I'll finish that last, and I'm not going to sand it or finish it. I start with 220, then finish with 400 or 600, depending on the wood. Oily exotics, tropical woods, that sort of thing, I'm going to go with 600. If it's something more open grained, I'll probably quit at 400. Now I'll pretty it up with beeswax. There are only about 8 billion ways of doing finish for turned woods, but this is as simple as they come, and it looks nice on hard, close-grained woods and oily exotics without any additional work. Then I'll finish the nose for the ferrule and more or less part it off. Then I'll cut it totally free on the bandsaw. Next, I'll drill a hole for the shank of the tool. Fairly simple to do. I just mark the center point. Then I'll use a spotting drill to start the hole. And finally, a regular twist drill just to drill to full depth for the shank of the tool. I improvised this little setup to force the shanks, which are very tight fitting, into the holes in the handles. Now you could do this by just shoving it against something, but the problem with that is that if you get a little offline, you could potentially bend the screwdriver shank. So all I did was drill a hole in this piece of wood, then put a second block of wood resting on the spindle of my mill drill, insert the shank, drive it home by cranking down the quill. Done. As I said earlier, I'm strengthening the tool by using a brass ferrule made from 5-inch ID pipe. You can do this without a ferrule, but the likelihood of the tool splitting increases dramatically. Plus, they look way more badass. The ferrule is just a piece of brass tube chopped off to length and then flattened on the grinder so the face seats cleanly against the shoulder of the handle. Then I'll use a countersink to gently chamfer the front face of the ferrule. Ideally, the handle should be turned just a hair larger than the ID of the tube. That, in turn, means that you don't want a sharp edge on the face of the ferrule, or it'll dig in, raise up a bunch of wood fibers, and then the whole thing will stall out and you'll have to start over. Next, I'll drill a hole. The reason for this hole is that you don't want the shank to rotate under load as you're trying to turn a screw. So I'll be putting a cross pin in. I was going to forge a little anti-rotation feature into the shank, which would actually be a much more robust way of doing this, but I decided not to since I'm doing a bunch of screwdrivers and all of them, this project included, are not forged. Anyway, obviously we're not doing that here, so I set the whole thing up on this jury-rigged little V-block for stability. So I insert the cross pin first, along with a little epoxy. Then I'll drive the ferrule home. I clean it up with some fine grit sandpaper, and here's the final result. Alright guys, hope you enjoyed this project. In a subsequent video, we'll make a Phillips head screwdriver. Thanks for watching, guys. If you like what we're doing here, please subscribe and make sure that you click on that bell so you get notified of all the latest videos. Want to buy a knife from me? Check out my modern blades at tacticsarmory.com. Digging the channel? You can support our video making efforts on Patreon. You know, I've been banging away on these videos for like 10 years, so I hope you'll show some love for all that hard work. Link in the cards and descriptions. Finally, if you're interested in making Japanese swords, check out my full line of Japanese sword videos where I show how to forge Japanese swords as well as how to polish them and how to make fittings, handles, and scabbards. WalterSorrellsBlades.com.